'cause I don't think about way back when. It takes two to love, but only one to...
Section 4.2 is on functions. And this should be a quick video because basically there's really only two things we need to talk about. We need to understand what a function is, and we need to understand what a one-to-one function is. So, what's a function? A function is a special type of relation. Now, remember what a relation is? A relation is a set of x and y values. Remember, we call the x values the domain, and we call the y values the range. So a function is a special type of relation, and in a function, for every value in the domain, in other words, for every x value, there is one and only one value for the range, in other words, for the y value. So, in other words, for every x value, there's only one y value associated with it. So for example, let me put down some points here. 3, 2, that's an ordered pair, right? 4, 4, that's an ordered pair. 5, 6, that's an ordered pair. So far this is a function because for every domain value, every x value, 3, 4, 5, there's a different y value, 2, 4, 6. Okay, what if I did this? What if I did 7, 6? Is it still a function? Yes, it is. People often say no because this has a 6 and this has a 6. That's okay. Different x values can have the same y value. That's fine. What doesn't work is if we had another point like 4, 9. Now this is no longer a function. Why is this no longer a function? Because look, we have this 4 here, and it has an output or a y value of 4, but this same number, 4, just like we had here, is also an output of 9. So a single x value, in this case 4, has two y values. That's when you don't have a function. Alright, so what's a one-to-one function? Well, a one-to-one function is a special type of function. So, just to be clear about this, there's relations, and then some relations are functions, and then some functions are one-to-one functions. So the way you can draw that is you can say, okay, there's one-to-one functions, and every single one of the one-to-one functions are functions, and then every single one of the functions is a relation. Or you can look at the other way, there's relations, and some of the relations are functions, and some of the functions are one-to-one functions. Okay, like that. So one-to-one functions are a special type of functions, and that shouldn't say functions, it should say function. And basically, it's almost like the same definition up here. For every value in the domain, x value, there's one and only one value in the range, y value, and vice versa. So this is more specific. In this case, every x value only has one y value associated with it, and also vice versa. Every y value also only has one x value associated with it. So remember when I was looking at this example here, when we only had these points down here, I said this was still a function. I said that even though there was a 6 here and a 6 here, that it was still a function because each of these two x values, the 5 and the 7, are only associated with one y value. 5's only associated with 6, and 7's only associated with 6. It's not like 7's also associated with 9 or something. So in this case, this is still a function. But what this isn't is a one-to-one function. Why not? Because we have a single y value, 6, which is associated with two x values. So it has to work both ways for it to be a one-to-one. Only has to work one way for it to be a function. A little confusing, isn't it? I think you'll understand it more when you see some drawings and diagrams down below here. In fact, well, let's just do this. Okay, so there's something else I need to say about both of them. In order to be a function, a graph needs to pass the vertical line test. And in order to be a one-to-one function, it has to pass the vertical line test and the horizontal line test. So what's the vertical line test, first of all? Alright, well, let me draw a vertical line. I'll make a big fat red line here. There we go. And the vertical line test is, if I want to know whether this blue curve here is a function or not, I slide this vertical line along and I ask myself, is there ever a time when the graph crosses that vertical line at more than one time? And I think the answer is going to be no, right? Right now it only crosses it, it's kind of fad, but it only crosses it here, now only crosses it up here, only crosses it around there, only crosses it down here, only crosses up there. It never crosses it more than once. So this first one is a function. I don't know yet whether it's a one-to-one function, but it's definitely a function. Okay, let's try the next one. If I slide this red vertical line along this red curve here, does it ever cross it more than once? Does the red curve ever cross the vertical line more than once? No, it's once, 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 once. No, it's also only once that it crosses it. So this is also a function. However, when you look at the bottom one, if you take a look here, if I take this vertical line, is there ever a time that it crosses this, that the blue circle crosses the red vertical line in more than one spot? Yeah, it happens all over the place. It's always covering it twice. Right now it's crossing the vertical line up here and also down there. If you slide it over here, it's crossing the vertical line up here and also down there. So this is not a function. It fails the vertical line test. So this is not a function. Okay, if it's not a function, it's definitely not a one-to-one function. So we're done with this question down here. But we still have some work to do with the first two questions, because we have to figure out whether it's a one-to-one function. How do we know if it's a one-to-one function? Has to pass the horizontal line test. So what's the horizontal line test? Well, it's almost exactly the same. You now take a horizontal line, and you ask yourself the same question. Is there ever a time when this blue curve crosses the red line in more than one spot? Yeah, absolutely. Look, right now it's crossing it in 3 spots. 1, 2, 3. So this fails the vertical line test. The horizontal line test. So this first question here is a function, but not one-to-one. Not one-to-one. Okay, let's try the second one. Does it ever cross the horizontal line in more than one spot? Well, it kind of looks like it might right there, but I think it's supposed to be getting closer and closer and closer to the origin, then hitting the origin, and then dropping below right away. So perhaps it's not the best example, but I think this is supposed to never cross the vertical line more than once. So yes, this would be a one-to-one function. Okay, so we'll put one-to-one. One-to-one function. I guess I don't need to put function and one-to-one function. I could just put one-to-one function. Okay, don't even need to look at the bottom one. We already know it's not a function, so it doesn't matter whether it crosses the horizontal line test, because we already know it's not a function. Can't be one-to-one function if it doesn't cross if it's not even a function. Alright, so now what we're going to do is we're going to figure out whether these are functions or one-to-one functions or neither. So let's take a look at this first question here. We have got some ordered pairs. So what you want to do is look for some common numbers. So in our domain, the x values, we have 4, 3, 2, and -6. Those are all different numbers. So far, it could be a function or a one-to-one function. Now, if we look at the range, the y values, we have 6 and 6 here, and then -7 and -5. Alright, so what does this mean? It means that 4, an input of 4 is an output of 6, or an x value of 4 is an output of 6, and an input of 3 also has an output of 6. Is that a function? Yes, it is. That's okay. It's okay if different x values have the same y value. So this is definitely a function. Is it a one-to-one function? No. Why is it not one-to-one? Because you have a y value, in this case 6, which has more than one x value. So it's not one-to-one. Okay, let's try the next one. So let's look for some common numbers. 12, 11, I'm looking at the domain here, the x's. 12, 11, -4, 12. Oh, we got 12 and 12, and 33. Okay, well if we look, we got 12, 4, and then we have 12, 19. So for a single x value, in this case 12, there's more than one y values. Is that a function? No, that's the whole definition of what a function is it has to, every x value has to have a different y value. In this case 12, the input of 12, has 2 outputs. That's not a function. Okay, this is called mapping. When you draw it like this, it's called a mapping. So again, is this a function, one-to-one function, or neither? Well, we've got a domain. The left side's the domain here, and the output's the range. We've got a domain of 2 and 8, and it goes to 6 and 8. And if you look, there's a single input of 2 that goes to an output of 6, a single value of 8 that goes to an output of 8. Yeah, this is a one-to-one function. Okay, how about this one? For the input of 5, the x value 5, it only goes to -5. For the input of -3, it goes to -5 and 8. Uh-oh, you can't have an x value that goes to two y values. This is not a function. How about this one? We have an input of 2 that goes to an output of 6, and we also have an input of 8 that goes to the same output of 6. Can that be a function? Yes, that's okay, right? It's okay for two different x values to have the same y value. So this is a function. Is it one-to-one? No. Why not? Because a single y value has more than one x. So this is not one-to-one. Last one. We have -3 going to -5, and we have 5 going to 8. Okay, just because they cross like that doesn't change anything. This is a function, and it's also one-to-one. Last question. Mr. Waj's students received the following scores on their test: 17, 18, 22, 25, and 31. Mr. Waj realized that the test was too hard, so he added 3 marks to each of their scores. Represent this function in the following ways. First way you want to represent it is using function notation. So function notation looks like this. You write f of x, or you could write g of x, or h of x, or m of x, or anything. What this means is a function, that's why we usually use f, but you don't have to, a function that's going to include the letter x in it. So somewhere in this function, in this rule that I'm going to put here, there has to be the letter x. So what are we doing to all these x values, or these input values I should say? What we're doing to them is we're adding 3. So what we're taking is the input value, the x value, and we are adding 3. Right? So we've got a function, a rule, that includes x in it. Is that true? Yep, there's the x. So our rule definitely includes x, and our rule is x plus 3. Right? These are the scores, 17, 18, 22, 25, and 31. That's the x numbers, and then we're adding 3. That's function notation. That's probably the hardest part. Second part is mapping notation. So that's where you do these bubbles, what we've just done up here. On the left-hand side, you write the scores: 17, 18, 22, 25, and 31. Now, what do those scores go to after I do this to them, after I add 3 to them? Well, the 17 goes to 20, the 18 goes to 21, the 22 goes to 25, the 25 goes to 28, and the 33 goes to 34. All I'm doing is adding 3 to each of them. Got to draw some lines to show which one went to which. If you want to change the order and have the lines crossing each other, it's up to you, but I'm just going to do it like this. By the way, is this a function, a one-to-one function, or neither? This is a one-to-one function, isn't it? Hope that makes sense. Okay, next one, using a table. Well, it just gets easier and easier. My x values are 17, 18, 22, 25, and 31. And my y values that go with it are 20, 21, 25, 28, and 34. That's no problem. How about as ordered pairs? That's easy too. One is 17, 20. Another ordered pair is 18, 21. Another one's 22, 25. Another one's 25, 28, and 31, 34. I think the function notation is the only one that could give you any troubles. Once you got that, you're kind of home free. Alright, hopefully that makes sense. As I said, all you're worried about here today is what a function is, what a one-to-one function is. Good luck with it.
It's a brighter day than ever before.